What one? Okay, again, for 4 marks, this is a lot of marks for a simple example. So 3, I write this. I like to just rewrite it. Okay. Now keep in mind the standard form of this parabola we've had the whole time. Okay. It's very clear that we don't have that. So we need a x squared, and we need it to take everything to one side so we can have equals to 0. So there's 2 things to do. But I first need to get rid of this square root over here. To do this, I need to do the following. I'm going to square this by 2. But if I square this by 2 on the left-hand side of this equation, of this equal sign, I also have to square by 2 on the right-hand side of the equal sign, right? That's the first thing, super important. What you do on the left of the equal, you always have to do on the right of the equal. That's the first thing. The second thing is why some of you might ask, well, why am I squaring? Okay, that's a very valuable or legitimate question. The answer to that is because you use your exponent rules, right? It's because the square root of x, remember that's what we want to get rid of, that square root. That can also be written as x to the power of a half. And to get rid of that, using your exponent rules, I have to multiply that by 2. That then immediately becomes x, and then those 2 cancel out, and it becomes x to the power of 1, and that's just x. So that's why you square it. Okay, it has to do with the fact that you can write this square root as x to the power of a half. Okay, so those are all the basic things that I want to say about this example. Now we need to just do it. So we've got 9x on the left hand side, and that equals, well, now you've got to be careful here. So I'm going to do this very thoroughly. What's written there on the right hand side is this. Okay, don't make a mistake and just, I don't know what you can do something very strange there. Don't do that. Just this is the correct way. So again, we have to go through it methodically, multiply each term with one another to find a solution. So we have, writing this in green today, 9x equals, now help me, x squared minus 4x, I think, minus 4x plus 416. Now, for the next thing, I need to get it in this homogeneous form. Okay, what I'm going to do, I'm going to take this guy over here. So I have x squared minus 8x, it's just these terms together, plus 16. If I take it over this equal sign, it becomes minus 9x, and it equals to 0. Take some time to think about what I did here, as this is very basic and you should really get this right, understand this. All I did is I wanted to write it in the standard homogeneous form. To do that, I first had to get rid of the square root, and then I had to get it all the terms with either variables or numbers. I had to get away so that I can have this homogeneous equals to 0. Okay, and as soon as I take it over this equal sign, the symbol changes, or the symbol. Cool. I'm gonna simplify it a bit. X squared minus, what's happening here, 17x plus 16 equals 0. Okay, now, again, now you're at the very start where we had all these examples. You need to write down factors for 16, right? So we have 16 times 1, 8 times 2. But the 16 times 1 is interesting because it seems that we can use these two numbers here to relate it to this number 17. Okay? So let's try this. I'm not doing the ABC formula as you say. I'm doing, most of these examples, I'm just doing it by inspection for first. Okay, I know that I need two brackets. So I have a bracket times multiplied by a bracket equals 0. Okay, and then these first entries are x always. Okay, and now I've decided to use 16 and 1 as my numbers. I know that it has to be plus 16, right? So I need to have either minuses in both or pluses in both. And because we have minus 17, I think I have to have minuses in both. Okay. If I test this guy now, again, just show you everything that needs to be done. This guy goes with that guy, and I also have to multiply the minus 16 by minus 1. Okay, so I have x squared minus 16x, then minus x, and minus 16 times minus 1 is plus 16. Okay, and so I get this, right? So I know this factorization is correct. And on the last step, I just have to write the solution. So we have x equals 16 or x equals 1. That's the solution. Okay, that's that. I hope that's clear. Because in these 4 examples, all you had to do is calculate the roots and solve x. And in all of them, you had a parabola. And I think this previous one where you had to deal with the... Oh, this mouse is up too. We had to deal with the smaller S sign. Oh my goodness, this mouse is crazy. Let me try this. Where you had to deal with this larger S sign, pardon me. That was the most difficult one. Okay, this one again, I feel was kind of basic, but you had to get this right. You had to realize that you had to write it in a standard form. To do that, you had to get rid of the square root, and to do that, you had to multiply by this exponent of 2. Okay, well, check what I did. We're moving on swiftly. For 6 marks in this exam, you had to solve simultaneous equations. Now this, I feel, is very basic and it's easy marks. And the only thing you really have to do is to make sure you don't make a mistake. This gets kind of interesting, I think. I mean, it's very basic now, but if you study any, again, engineering related thing in university next year, you'll get to do a lot with how you write these things in a matrix. And then even there's software that can help you to solve these things. So lots of interesting things, I think, to look forward to at university. But for now, this is very basic. So we're going to start by, I always do this by numbering it. That helps me explain it better. It also helps me not to make a mistake. So first one, I'm going to name equation 1. Okay. And the second one, plus 9x squared equals minus 1. That's equation 2. I really feel that dealing with and rewriting equation 1, because I already have a pure y there, is going to be easier. So I'm going to rewrite 1. I'm going to say, I'm going to take over that y there so that it can become positive, and I'm going to bring over that 2 here, okay, so that I can just have y equals something. If I rewrite 1 as the way I want it with very little effort and fuss, I'm taking that y over and I get 3x minus 2. And this I'm going to rename as equation 3. And what I'm going to do now is I'm going to substitute 3 into 2. Okay, so I get 2 multiplied by 3x minus 2, right? Plus 9x squared equals minus 1. Okay, let me just see if I did this correctly. There, I need a square bracket. Okay, this needs some simplification. Let me get a different color. What I'm going to first do is I'm going to simplify this guy over here. So this 2 is just going into the brackets. And this gives me 6x minus 4 plus 9 squared x. I'm going to bring this 1 over because I want this homogeneous equation, right? So it's plus 1 equals 0. Now, moving on to this right side, I have, and I'm going to write this down in a little bit of standard form so that you can start seeing something of a parabola popping out. There I need a plus 1, I guess. So 9x squared plus 6x minus 3 equals 0. Does that look okay? So I've just taken this guy over here and I've simplified it. Okay. The first thing that pops to me now is I have to also simplify this equation. I can see that these are all factors of 3. So I'm going to divide this. Divide by 3. And I get 3x squared plus 2x minus 1 equals 0. Okay. Solve this. Let's do this by inspection, right? Make it a little bit more difficult. We know that this is to be 3x and that has to be x, right? Because we've got a 3 here. And then we've got a 1 and a minus 2, or minus 1 and a plus 2. So that's easy because we know the factors of 1 is just 1. And because it's a minus 1, this one is going to be minus, and the other one's going to be plus. Okay, testing this. Let's see where we get at. We've got 3x squared. Okay. And then we got, maybe I've got this the wrong way around. I think that has to be like that. Okay, yep. We've got 3x squared. We got 3x times 1 is plus 3x because we've got a plus 2 here. Okay, plus 3x. X minus 1 times minus 1 is minus x, and minus 1 times 1 is plus 1. Okay, so 3x squared plus 2x plus 1 equals 0. So we know we're doing the right thing. Okay. Final part of the solution is going to be x equals, well, it has to be a third, or x equals minus 1. This comes from here, so see if you agree with that. And then we have to still solve y, right? But we have this neat equation 3, which relates y to x. And now we can just go and plop these x's into that. So we have y equals 3 times a third minus 1 minus 2. Okay, that equals, well, 1 minus 2 equals minus 1. Or y equals 3 times minus 1 minus 2. That equals minus 5. If I'm correct. Okay, so we have a solution here where I now have simultaneous equations that I had to solve. Because there was a square root there, I knew that I would get 2x solutions, and by default then also 2y solutions. I had to just solve these equations simultaneously, and I did this by just selecting to rewrite equation 1, and we named it 3. I got some kind of equation over here that looked a lot like all the equations I've seen previously. I simplified it a bit, and then I proceeded to factorize it and got my set of solutions. And then I just used this equation 3 relating y to x to obtain my 2y solutions. And that was that. And that's 6 marks. I think that's kind of neat. For something that's very simple, it just takes a little bit of time. You shouldn't make a mistake, but I think that's kind of an easy 6 marks. Okay, and that brings us to the last example. And I'm going to do this in this video as well, I think. We get this entire question 1 of 2018 done in this video. This example solely relies on your knowledge of exponents. And more expressively said, exponential laws to solve. Okay? You're given the fact that 3 to the power of 9x equals 64. But crucially, these two things are equal, so that also equals 5 to the times of the power of square root p. Okay? The first thing that has to jump out of the page is the following. You can write this as 3 to the power of 3x times 3. If that's clear. 3x times 3. Okay. And the reason why I say that is because what they're asking here is to give the solution in terms of something in the brackets with only an x there to the power of 3. Okay, so you know this is legal because you know your exponent laws. And even stronger, I'm going to write this a little bit more elegant. 3x, 3 to the power of 3x to the power of 3. Okay? So that was the first thing to realize. The second thing to realize is that 64, well, 64 is 8 times 8. So it equals 8 squared. That's not really helping you. You need something to the power of 3, and that is that 64 equals 4 to the power of 3. Okay? So that's the first set of clues. Because then you can go and say, well, Thank you very much. 3 to the power of 3x equals 4. Okay. That's very simple. And if we look at what we're aiming for, this little part over here corresponds to that little part over there. So we got it. We know what they have to fill in there, and that's 4. Okay. So that's the first thing. The second thing, and I'm going to address this 5 square root p, because I have to have square root 5 to the power of square root p. All I have to do to get that is to square root the 5, right? So let me write that out. I'm going to bring that over a bit and say 5 square root p equals 64. I might, let me think about this. I'm going to, let me first just write that. And what you write on the first side, so on the left side, so I've now raised this to the power of a half. And we had earlier that that to the power of the half is just simply square root of 5, right? So the square root can also be written as the power of a half. But what you do on the one side of the equation, you have to do on the other side. So you have 64 to the power of a half. Okay. But we just had earlier that 64 also can be written as 8 squared. So what I have now is 5 square root 5 to the power of p equals 8 squared to the power of a half. And that just simplifies down to 5 square root p equals, well, these two, again, from your exponent laws, are just kind of cancel out, and that's just 8. Okay, what does this translate into? I have this part here, and this is this whole denominator here. Okay, this was step 1, this was step 2, and now the final step. It's a little bit of a pain in the ass. I have to sort of deal with this, what's going on here. Okay, so I'm going to revisit this over here. 3 to the power of 3x. I'm going to say that that is also written as 3 to the power of x to the power of 3. This is starting to look a little bit more like that, right? But I still need this minus 1. And what I can do there is say, well, to get it in that form, that's 3x minus 1 to the power of 3. Okay, that's correct. If I simplify this now, that equals 3 to the power of 3x minus 3. Okay, so all I'm doing is I'm multiplying that 3 with these two exponents over here. Okay, that's allowed. So this here, if I multiply that 3 into this, I get that. Now, I hope you see over here that this part I already have the solution to. And the other part is just, well, I know that this is also written as 3 to the power of 3x multiplied by 3 to the power of minus 3. Okay, that was the third part. I hope that's clear. I'm going to start assembling this solution now. So, this I've rewritten here. I've multiplied that 3 in, and I've simplified it and written it as the product of 2 terms. Okay, so final solution is, I'm going to write it here on the right and corner 3 to the power of x minus 1 to the power of 3 divided by 5 square root 5 to the power of p. Okay, this equals, well, this 3 to the power of 3x multiplied by 3 to the power of minus 3. And this thing in the denominator I've already calculated a value for, so I'm just going to plug that in. Okay, and in the last step, I had the value of that thing over there. That was 4. Okay, so we have 4. Now, 3 to the power of 3 is 27. But this is 3 to the power of minus 3. So this is 1 over 27. So it's 27 times 8. And that's our solution. Well, I hope this was clear. It's kind of a little bit crazy, but you have to tackle it in parts, I guess. Go and look at how I explained this again, how I did this. I did it in 3 parts, right? I simplified it a bit first and dealt with this 64 because I have to get values, right? And I got a 4. And then I did the second part. So this was the first part, dealing with this. The second part was dealing with this, and I also got a number out of that, which was 8. And the third part was just rewriting this difficult equation here, and using exponential laws to realize that I could get it as a product of 2 numbers. And just in the final step, just substituting it back into it. And that was 23 marks of the exam paper of 2018. I hope you enjoyed it, and I'll see you next time. Thank you so much.